Okay, this is your mini quiz number 2 with acids and bases. So here we go. So the first two are talking about Bronsted Lowry acids and bases. And so this one is going to be an acid is going to donate a proton, and a base is going to accept a proton. Okay, and so to explain these a little bit, or I'm going to show you these equations when we put an acid or base in water. So a Bronsted-Lowry acid and base is just an expanded definition of what an acid and base is. Okay, so how we're gonna expand this definition? Well, if I take something like hydrochloric acid and put it into water, what's going to happen? All right, and so what's going on is we're saying we don't know what this is. Is it an acid? Is it a base? Is it something else? Is it neither? Okay, and so what their definition is saying is if it's an acid, anything that's an acid will donate a proton to that water. And so in your equation, you're going to see that it's going to come out to be H3O plus chlorine minus. So what's happened is this HCl has donated a proton to that water to give us H3O plus, and then Cl is left by itself, which becomes minus because it was neutral here when it lost that proton and now became a minus. Okay, so when you have an acid that's added to a water, this is a big indicator that we're trying to prove Bronsted-Lowry's definition. On the other hand, an acid is going to accept. So when I have something like NH3 added to water, how do we know that this is going to be a base? Well, we see that there's no hydroxide in this water, in this NH3, this ammonium, and so that means this is not a Arrhenius base, because all Arrhenius' base always has this hydroxide group in it. Well, when we put this in water, what we see is that it takes one of these protons, it accepts a proton from water to form NH4 plus, and then it forms that hydroxide ion over here. Okay, and so we see that this, because it's a Bronsted-Lowry base, it's going to accept that proton, and up here, because it's a Bronsted-Lowry acid, it's going to donate that proton. Okay, so that explains those two. Down here, which of these is a strong acid? So it's got to be an acid, which all of these are, and we give you a list of which one is strong, and it's going to be nitric acid. Which one of these is another strong acid? So once again, from our list, it's going to be perchloric acid, and this is just straight memorization of your list. That list can be found on the 3rd or 4th slide of your notes for this unit in Canvas. Which one of these is not a strong base? So if it's not a strong base, what we need to know is you have 8 strong bases. If it's not one of those, then it's going to be a weak base. So 4 of these 5 are going to be strong bases. One of them is not, and that one is aluminum hydroxide is not a strong base. Okay, and acids taste, well, if we remember acids taste, in most fruit is acids, in fruit like lemons and lime and oranges, most of them have a sour component to them. Acids taste sour. Okay, acids make litmus paper turn, and this is just from your notes. Acids turn things red, bases turn things blue. All right, so there you go. Bases feel. Well, most bases are some type of cleaner, like soap. Soap feels slippery. Okay, down at the bottom. So I've already given you the equations here. We're going to plug them in if we need to. So what is the pH of solution with a concentration of hydrogen of that, and is it an acid or a base? Well, the good thing here is that my coefficient is 1, so that means I can look at just this -8 and say, okay, and because this is hydrogen, the pH is going to be 8, and on the pH scale, an 8 is going to be a base. Okay, number 10, what is the pH of concentration of hydrogen? Now, since this is not 1, I'm going to have to use my calculator. This is a negative 12 here if you can't read it. And is it an acid or a base? So how do I do this in my calculator? I take the negative log, because I'm trying to find a pH. I need to find a pH. I'm going to be using this formula here, the negative log. Here's your log button. And then it populates that parentheses. Well, the concentration of H is right here, 2.3 times 10 to the negative 12. Close your parentheses, and you should get, let's take this out of scientific notation, and you should get 11.638. But I said to put this, use all, in all of the math problems, you should be using 3 sig figs. So 11.63 stays at 11.6. And because we're in the pH scale, so pH equals that. And then that will be a base as well. Okay. The bottom one, what is the concentration of H? So the concentration of H equals if of a solution when the pH is 4.4. Well, because I'm looking to find a concentration of H, this is my formula, all right? And because I'm finding a concentration, I need to be in scientific notation. We said that in class. So I just take, I put 10, exponent button, to the negative, the given pH is 4.4, and that's the answer that I get. Now, that's not scientific notation, so the easy way to put it in scientific notation is to do second DRG, scroll over to the science, press enter, and that should put it right into scientific notation, which would be 3.98, 3 sig figs, so it stays at 8 times 10 to the negative 5th power. And there's your answer. Okay, so that ends the second quiz. I hope that helps.